Yep. Okay, so, Midna. Who's Midna? My dog. Why are we doing one about my dog? Because, I don't know, I love my dog a lot. She makes me happy. Midna can run 30 feet per second. Totally made that number up. Have no idea what's reasonable. It's wishful thinking about my dog, who mostly moves at the pace of a sloth, but whatever. I am a quarter of a mile from the house. The house is between Midna and I, and Midna is 20 feet from the house. Okay. If she maintains her speed, how long will it take her to reach me? Can we agree that this story problem is talking about location of things, a speed, and I'm trying to figure out how long? I guess this should be a question mark here. Okay, all of those things should scream to us that we need to use distance equals rate times time. Right? We have some distances given to us. We're talking about the pace at which she goes, and we need to know how long until she gets there. Because the majority of the time, I shouldn't say the majority, a lot of time with story problems, we're given information where you need to actually figure out what the formula is you need to use to start with, right? You're dealing with perimeter, so you need to do perimeter. Okay, you're dealing with how much paint you need for a wall, that's area. Okay, distance equals rate times time is the one you see all the time in your science class. I cannot stress this enough. In a location story problem, you should draw a picture. Pictures are super helpful in story problems often. Doesn't matter if you're a fantastic artist when you go to draw your picture. No, so here we go. Let's do a picture here with Midna. What does it tell me? I am a quarter of the mile from the house. So what am I going to draw? A house. So here's my house. What else am I going to draw? Well, someone else is in this. I am a quarter of a mile from a house. So what else do I need to draw? Me. So here's me. I'm a giant. I'm as tall as my house. And that's a quarter of a mile. What else do I need to draw? Midna. Where's Midna?
20 feet from the house.
Okay, 20 feet further, right? The house is in between Midna and I, so Midna's over here, right? So here's Midna. Midna has a bushy tail. She has long floppy ears, so she gets floppy ears there. Here's Midna. But I had to draw Skeeter. It used to be Skeeter. She had pointed ears, so she kind of looked like a witch, because she had like on a witch hat, but Midna has floppy ears, so there's Midna. Doesn't matter that Midna just looks like a flat block. No, it doesn't matter. Okay, Midna's how far? 20 feet. Here's my lovely picture. Doing okay? I need to find the things I need to fill into my formula. So my formula says distance equals rate times time. I need a distance, I need a rate, and I need a time. What's the rate for this problem? That one's given to us. 30 feet per second? That one's just given to us. Okay, distance. I'm trying to find the distance Midna needs to run. Looking like a big old doofus. Maybe I should really put her ears like on top of her head. Can you have dogs with like floppy ears that when they run, they just end up flipped inside out on top of their head? That's what Midna's ears do, and it drives my daughter crazy. Okay, so Midna runs to me. How far does she need to run to get to me?
20 feet.
Just 20 feet?
Oh.
Okay, so she needs to run 20 feet plus 1/4 of a mile. How do I do 20 feet plus 1/4 of a mile? Ooh, I should change those miles into feet. Anybody know how many feet are in a mile? It starts with a 5. 5,000.
5,000. Oh.
Yeah.
280? There are 5,280 feet in a mile, so even if you forgot, you could Google it, right? So 1 mile is 5,280 feet, but Midna only has to go 1/4 of a mile.
Oh, yeah.
So what are we gonna have to do with that? Divide by 4 or multiply by 1/4. So let's see, if we divide by 4, that's gonna be 1,320 feet.
30 feet per second. Wait, did you divide the 4 by the 5,000?
Yeah, I did 5,280 divided by 4, or multiply times 1/4. So how many feet total does she need to go?
1,000.
1,340 feet.
Wait, why 40?
Because I need this additional 20 feet over here that she still has to go.
Oh.
Right, I need to add that on. We don't know what time is, right? That's our variable. We're leaving that as it is. So if I say distance equals rate times time, I'm going to say 1,340 equals 30 times t. Yep. I took that 5,280 and I took 1/4 of it. Right, divided it by 4. Four, 2. And 2/3? Is this a 0.6 repeating? And
Yeah, 44.
44.6 repeating? Okay, so 44.6 repeating, 44 and 2/3. I mean, we're talking about seconds. I don't know about you all, but I have a hard enough time keeping track of 1 watermelon, 2 watermelon. Am I going to be able to keep track of like 0.6 of a watermelon? Probably not. So what would we probably say? How long is it going to take a minute to get to me? 45 seconds? Let's just go to seconds. I mean, a decimal of a second. I guess we're not trying to like win Olympic races. If it was Olympic races, maybe it would matter.